So as we have demonstrated in our problem identification, our group identified two solutions for isolating those kind of offsetters. The first one would be to lock the internal parts of the PSV so as to prevent it from relative motion and eventually prevent it from dislocation. The other solution would be to eliminate the external vibration that might be induced from a transportation vehicle. The first artifact that we have designed is the internal locking clip. The function of this clip is to lock the internal parts of the PSV from moving so that we avoid any chance of them getting apart or eventually making the valve deviating from the setting pressure. After calibrating the valve, and in order to prevent any internal dislocation of parts, the aim from that clip is to be admitted from the outlet flange so that the head can be interlocked at the distance between the disc holder, which is a movable part, and between the disc guide, which is a fixed part, exactly at this space. So eventually, when we put that clip in this area, and the clip is fabricated so that its dimension will resemble the exact dimension of this space in our valve, that clip head would stay in here in this location during the valve being transported from the testing facility to the operation facility, and then before putting the valve finally into operation, it will be took out. The clip is basically made from two parts, the arm and the head, and they are assembled together by a thread connection here. After admitting the clip into the valve, the arm will be turned so that it can be took out of the valve, and only the head would stay. But before putting the valve into operation, we should take the head out of the valve, and that's the function of this location here. A string cord would be fixed to the head, and it will be extending beyond the outlet flange of the valve so that it can be pulled, and pulling the head out of the valve before putting into final operation. Now, after we locked the internal parts of the PSV, preventing it from motion, we have to think about a tool or a container that isolate the external vibrations from being transmitted to the valve. And that's the function here of our PSV transportation pallet. The pallet consists of two parallel sheets, and in between there are several wire rope isolators arranged at a specific or definite setup, whose function is to prevent the vibrations that might be induced from the load roughness into the lower plate of the pallet from being transported to the upper section of the pallet, which is the valve. Also, we have here 4 clamps whose function is to maintain an upright posture of the valve all the time during its transportation from the calibration facility to the operation site. We can see here also that we have an external clamp that might be clamped around the top part of the valve, and then by the use of flexible straps that are connected to the top plate of the pallet, those straps will be redundant shall any of the clamps fail during transportation, so that they can provide again the upright posture to the valve, preventing it from toppling or from falling, and maintain a correct arrangement for the internal parts. Now, the last part of our pallet is the 4 columns, which has 2 functions. First off is allow for rigging or for lifting of the whole pallet from the testing facility onto the transportation vehicle. Also, the whole pallet, after being lifted on the vehicle, should be tied to the body of the car, of the vehicle, so that it prevents it from moving or from hitting on the sides of the truck. And that's the second function of the arms here, or the columns here, where we will tie the pallet to the vehicle or to the truck. Having a closer look on the clamp, we will show you now how it functions. The clamp consists of two parts, the clamp arm and the wedges. The wedges are welded to the top plate of the pallet, so they are fixed. And the clamp arm is allowed to slide up and down along a certain machined groove inside the wedges, so that it can adjust its location, allowing for larger or smaller space for the inlet flange of the transported valve. So we can imagine when that arm is retracted to the top of the wedge, it is allowing for a larger size of an inlet flange. And when it slides down the wedge, it is decreasing the space allowed, and in that stance, clamping a smaller size inlet flange. So after adjusting the location of the movable clamp arm so that it clamps on the inlet flange of the valve, we should lock it in this location, and here comes the function of the screw. That screw is extended along inside the arm, and the other end of that screw is sliding on a horizontal groove machined in the top plate of the pallet, so that when we fix the location of the arm on the inlet flange of the PSV, we would tighten that screw, preventing it from further movement.